Right. I think it's a good time. I see folks starting to pile on in here. Welcome all. Thank you for joining us today. I do want to just give some housekeeping items. We'd love to keep this as interactive as possible. So if you have any questions for us or comments, please use the Ask a Question tab or the Comments tab. Let us know how you're feeling, what you'd like to learn, what you'd like to ask the speakers directly, and we'll answer them throughout today's presentation. I did introduce them earlier, but just a proper introduction from VMware. We have Venki here on the right, and dialing in from Madrid, Spain, special guest speaker from Protegrity, we have Marco. Without further ado, I'll hand this off to today's speakers. Here you go, y'all.
Thank you, Jay. Welcome everyone for today's talk. We're going to be covering about how Greenplum, Tanzu Greenplum and Protegrity works together to ensure that we can protect user data, protect their privacies, and also separate duties so that you can come up with policies so that you can have defined roles and access roles for different users of your database system. A brief introduction on VMware Tanzu Greenplum. Greenplum excels in the data market space, especially in the private cloud. It's used as a critical application for storing and mining data, very large data for many enterprise and government customers who have a lot of regulatory restrictions for data sovereignty. They have petabytes of data that come in from different sensors and different sources, so it needs to scale, and also should have a rich analytical functionality so that they can deliver high quality content and value to their users. Because it's in a critical path of their application, it needs to be a very established mature solution, and it has billions of dollars of investment. Greenplum was started in 2004. Each time, each iteration, we have grown stronger and stronger, and we have built a wide variety of customers in different segments, starting from finance and government agencies, security agencies, airline industries, telecommunications, so different spaces. We have focused our attention on large customers who have big data challenges. Greenplum, as you know, is built on Postgres, and Postgres over the years has become the foundational technology. If you can see Amazon Aurora, if you even see Alloy DB, Postgres is an integral part of every customer's workload. Every single data vendor out there needs to have a Postgres-based solution. What is great about Greenplum is built on Postgres and built on all of the innovation, 30, 40 years of innovation that comes, and the innovation is coming strong every year. Postgres has a limitation that if it has more than like 50 terabyte, 100 terabyte, it doesn't scale very well. It cannot, and that is number one. Number two, it can also not scale for analytical queries. Postgres was predominantly built for transactional queries, so quick access, very index heavy query operations, but it does not scale for long running queries, hours or half an hour long queries. When you scale it to Greenplum, Greenplum can be viewed as like multiple Greenplum or Postgres instances coordinated with each other, delivering a value, right? So whenever the same query that used to take hours in Postgres now takes in a couple of seconds, couple of minutes in Greenplum. So a brief overview of the structure. So Greenplum is a shared nothing architecture. What that means is the data, say for example, 10 petabytes of data is split into different segments. So Greenplum is made of collection of segment nodes, and a segment node is made of multiple segments, and each segment has a portion of the data, right? So most of the data is randomly distributed or hash distributed, right? So each segment has a small nugget of that information, and it together with all of the, if you union all of the data across all of these segments, it's the original table that you have. So you can have billions of rows, but each segment will have a small percentage of that. So that's how it tries to parallelize. So if you have two tables where you're joining, for example, like order and line item, you just distribute it so that the segments that are the portion of the data that are there in each segment can perform the join operation. So you are co-locating the different tables, right? And because of the co-location, you get parallelism. So Greenplum has a coordinator that brings in all of the user requests, whether it's pSQL, whether it's clients, and then the coordinator generates a plan. It's where the query optimizer and the metadata, all of those reside. Once it generates the plan, it'll just dispatch it to the different segments, and the segments is the one that manage the data, process the data. And all of these segment nodes are connected by a high-speed interconnect, which can we can do broadcast or redistribute all of those operations. So the key for us to make Greenplum fast is one of the first foundational aspect is data distribution. So we can distribute the data either by distributing a hash distribution on a particular column. So say for example, if you have order and line item, then you could distribute it by the order key, right? So because you're usually looking for the order and its line item based on order key. So whenever you do join operation between these two um, tables, you are always going to use the order key as a join column. So if your distribution of both the order and line item are by the order key, then the join operations at segment level is co-located, right? So, but there are many times where the data does not have a particular characteristics where you can go and figure out which is the distribution column. For those kinds of tables, you do random distribution. A classic example is, say, for example, you're trying to clean the data in your ETL operation. You're just dumping the data. You have to still figure out the data. You have to clean all of the data. You would add it as a randomly distribution data. Or if there is a table that is joined on multiple different columns with for different queries, you don't particularly want to pick one. So then you would pick randomly distributed data. Another one is replicated data. If you have small amount of data, say for example 10,000 tuples, you don't want to distribute it, so you can replicate and keep a copy of it in each segment. This is usually like the small table that you join with a big table to prune things. Those are the different things. So till now, what we have covered is like a basic 101 of Greenplum. So, and this Greenplum this Greenplum instance can run anywhere you want. It can run on bare metal. It can run on public cloud. It can run on vSphere. So the good thing about Greenplum is the user can define what are their infrastructure and apply those particular infrastructure. So we have many customers who have multiple instances on bare metal while still having other instances on virtual. All right. So coming to the core topic that we are going to be, Marcos and I are going to be focusing today is on security. Greenplum provides a wide variety of security tools. So we provide masking, access control, authentication rule, auditing, how the tuples are being changed. So we don't have enough time today. We're going to just touch on one of these aspects, which is data masking today. So data masking is a process in which you obfuscate some or hide sensitive data so that you don't reveal it if you don't have authorization, or when you store it you totally completely mask it so that nobody can access it, right? The Greenplum enables two means to do obfuscation of data by data masking. So the first one is called generated column. So imagine you have a social security number, or in Europe you have national identification number, and only the last four digits you want to be visible, and you want the previous digits to not be visible. So while you're inserting the data, so say for example, if you have tax forms coming in, it has the national identifier number or social security number. You want to, when you insert it into the database, you want to make sure that only the last four digits are available. So you want to mask the rest of it, that no one will ever do it. So this kind of functions, or you can have a user-defined function that can randomize the data set, right? That column. So those are the things you can use. You define it while you're creating the table. But the benefits of this is that you, number one, mask the sensitive data. You can never retrieve the original data. It has improved query performance because you've already done the masking and you're storing it efficiently. It's a simple data model and it's consistent, right? Only restriction is do not use it as a distribution partitioning or a primary key. it should be a function that is deterministic. That means every time you apply it, it always returns the same results. Okay, make sure that that generator column don't have default values, and there are a couple of other things like don't use system columns like table OID or something. So there are some restrictions of how you get to use the generator column. So let's do a quick example. Here's a table, as I mentioned. I want to overlay the credit card number or social security number. I want to mask, right? I want to mask I only want to keep the last four digits and the rest. So when I insert Mickey Mouse's data with for credit card number, it masks everything except the last four digits. This is how a generated column works. Okay. Postgres anonymizer. Greenplum, since I mentioned before, Greenplum is built on Postgres. So any extension that is there for Postgres can easily be adapted to now serve for Greenplum. So Greenplum Postgres Anonymizer is a tool where you can anonymize sensitive data. It allows you to do GDPR as well HIPAA, different kinds of regulatory things. It enables you to do that. Right. So the way Anonymizer does is you come up with like security labels that enable. So you come up with rules as security labels, and you can assign those rules for different users. So similar to generated column, a static masking is to permanently overwrite sensitive data. The difference between this kind of static masking and generated column is that this is like based on a rule that you enable, right? Let's do a simple example. You have a raw data, you have a full name, employer, and zip code. You come up with rules saying that, hey, make it into a dummy name, dummy customer, company name, and a random. So you came up with security labels, and then you apply those security labels to that particular table, which is the customer table, right? Now what happens is the actual anonymized data now becomes where the name and the employer are anonymized, as well as the zip code is randomized, right? So once you do static elimination, static masking, it's not static masking, you will never be able to retrieve the original data. But there are many cases. I'll give you an example. There was a user of Greenplum where they had an intern who was working in their finance division, and they didn't have security policies, and they had he could access all of the social security number. What they did is, by accidentally, the intern emailed out a person who didn't have privileges the list of all of the employees in a particular department with their security number to a person who didn't have access to it, right? So what you want here is you have different kinds of users who will have different kinds of roles and privileges to see the data. So you want to have the original data to be raw and accessible only to a select few users, and all the other users you want to anonymize it so that they don't have all of the information. So here, for example, you have a people data, the same like similar to customer. You have name, last name, and phone number, and you want to anonymize something, right? So you come up with security labels saying, I want to anonymize the last name, and I also want to partially mask the phone number so that my phone number is like, not visible to everybody. So I have a user called Skynet, and I want to say the Skynet or this intern, for example, will only see masked data. They will not see the original data. So if I'm the roller Skynet, Sarah Connor is converted into the last name is anonymized, and the phone number is masked so they cannot see all of the digits of the phone number. However, if I was the DBA, sorry, I was the original author of the data set or the user of the data sets with full privileges, I will still see the raw data. I won't see the anonymized raw. So this is like a brief introduction of some of the masking capabilities that Greenplum provides. For a detailed understanding of all the other security tools that come with Greenplum, please go to our documentation or reach out to us. All right, I'm going to hand it over to my colleague to then proceed with how Protegrity adds value on security with Greenplum.
Thank you, Venki. I just stole the screen sharing from you. Please let me know if you can see
Yep,
it.
I can see it.
Fan-
Thank you.
Fantastic. Great. So, quick introduction. My name is Marco Carmona. I'm Director of Solution Engineering for Protegrity in EMEA and Asia Pacific. And a quick intro also about Protegrity. Protegrity is a data security company who's been around for more than 20 years. We've got more than 100 patents on mostly tokenization, which I'll explain in a minute. We're focusing on data protection, data privacy, and data governance. We're a recognized leader by Gartner in data security in our space. And as you can see, we've got clients in all kinds of vertical, among the largest customers, largest companies in the world. So we do data protection. So what does that mean? If you look at this number here, this is the date, and this is the 25th of October 1980. That's a sensitive piece of information that might be stored in your customer table or in your data lake or in the cloud. Doesn't really matter where. It could be, again, on premise, in the cloud, in Greenplum. And this piece of sensitive data can be protected in many different ways. The first one we see here on the left-hand side is encryption. Most of you are probably familiar with encryption. That means creating a ciphertext using an algorithm like AES-256. So it's secure. It's a valid way of protecting data, but it's not very usable, because if you want to store this ciphertext, you need to change your data type in your database, or the applications need to change to be able to interact with a ciphertext instead of a date field. And this is why we typically recommend customers to use tokenization. And this is what a tokenized piece of data or date looks like. Here we have the 19th of February 2001. So it's still a valid date. It can be stored in the same column and same data type of the original one, and it's really fast. Protegrity has a patented vaultless tokenization method, but there's also a way to apply format preserving encryption, or FPE. That's the FF1 algorithm, and the output is very similar. The difference is really in the way the data is processed. So with tokenization, we use a substitution algorithm, whereas with FPE, we use several cycles of strong encryption. Then we have hashing. It's not format preserving, and probably you're familiar with hashing. That's, again, one way only. It's not reversible, whereas tokenization, FPE, and encryption are reversible. So we can detokenize or decrypt the data. Then there's masking. Venki already talked about masking, static masking. We can do static masking too, but we can also do dynamic data masking. And that means that data can be protected at rest, can be encrypted or tokenized at rest. And then dynamic masking can be applied on top for certain users that are not fully authorized. And then there's also a method for anonymizing data, which is not reversible. And that's, for example, through generalization algorithms. So if you're looking at a date of birth, well, if you anonymize a data set that contains a date of birth, then the date of birth could be anonymized to an age range, like this person is between 40 and 50 years old. So these are different ways to apply data protection, mostly at rest and in use. So how does that work in a Greenplum cluster? Likely, Greenplum cluster has more than one node, so that means multiple Linux servers, and each server has a Protegrity agent. So let's start from the left-hand side. There's what we call the Enterprise Security Administrator. That's the main appliance where we define the security policy. And by we, I mean security officers, typically. So whoever is responsible for the security policy. And then in each Greenplum node, we'll have a database agent that's called a PEP server that receives the security policy that we create in the ESA server. And then it applies the policy locally in the database. Then whenever a user protects or unprotects data, we generate logs, and those logs go back to the ESA for the security officer to read and know what's going on, run reports on, etc. Now, this same architecture, again, works in every single node. So every node is aware of the policy that they need to use. Then there's a database component that's also installed, and that's a set of user-defined functions, UDFs, to protect and unprotect data. And we'll see that in a demo in a minute. If we look at a table that contains sensitive data, we typically look for what we call identifiers. So those columns that uniquely identify a person, for example. Now here we're showing you an example where almost all fields are sensitive. So we have a first name, a last name, an email address, a national identity number or a social security number in the US, a phone number, an address, the city. And as you can see here, the city is probably not a good candidate for protection because there's the fact of knowing that someone is from Houston is not giving away any personal information, right? And the postcode. The postcode might be sensitive because in some countries, like in the UK, it narrows down maybe a building or a few buildings, so it might be sensitive. So once we define what columns need to be protected, this is the process that we typically follow. So starting from the left, you probably have your data stored in tables that contain clear data. So the first thing we do is we need to apply protection. This is a one-off operation. If we do it on SQL, that's an insert into a new table. Let's call it PII underscore protected. And we call the Protegrity functions. The PTY protect for name, for date of birth, for whatever, any fields that we consider sensitive. And once we're done, we drop the original table. So the original table is deleted and we only keep the protected version. So that means that at rest, we only have the protected version of our data. And how do we get the data back? Well, we can create a view, for example, a SQL view. So you see here the code, create view as, select, and then the columns that are not sensitive without any function, and then the unprotect function for name, for date of birth, etc. This way, whoever accesses the view will see the data according to the policy. So the functions will do two things. The first, will check the policy locally. If you remember, the policy is stored locally on the node. So there will be a local check of the user, whether the user is in the policy, what role the user is in, what they can do with the specific data element. So they might be able to unprotect the name, but not the date of birth. So it goes column by column or data element by data element, and then returns and then applies the unprotection or the detokenization functions. And so users that are fully authorized will see the data in the clear. Users that are partially authorized might see data masked. And users that are not authorized, they will get whatever we define in the policy. It could be all null values, all tokens, or even error messages. So these are the options. And this is what we typically do in an existing environment that stores sensitive data. Now, this is again a one-off. If you are thinking about a new project where you want to protect data from the beginning, you might want to think about adding the Protegrity functions to your ETL process, which could be outside of Greenplum, so right before Greenplum, protecting the data and landing the data already protected in your staging area, and have the user-defined functions in Greenplum to unprotect your data. Or if you use an ELT approach, then you just load the data, you apply scripts like the one you see on the screen, and then you get your data protected as the second step. Now, in the demo, we're going to see three personas. The first one is Nathan, our security officer. Nathan is allowed to create policies in ESA, but does not have a user account in the database. Then we have our system administrator, Frank or Ed Wood. And typically, system admins do not have the privilege to see clear data. But of course, they see the data as it's stored in all the tables to do their daily tasks like backup, restores, and so on. And then we have our finance controller, Martha Ann Sanders, who needs to see all the data in the clear. And actually, I've added a third user. We'll see now someone who's in the middle, so can see some columns, but not all of them. And we'll see that in a second. So we'll start from the policy definition, and then we'll go to the database, to Greenplum with the SQL client, and I'll show you what the data looks like from every user's perspective. So next thing I'll do is show you the Enterprise Security Administrator interface. This is our dashboard. I'll make this a bit larger so you can see it better. This is where security officers know exactly what's going on, how many nodes are connected. Right now, I'm using a single test instance of my Greenplum, so it's just one node. But if you have a 20 node, you would see here 20 nodes and their status. If they're all the PEP servers are connected to the ESA, and you'll see that all 20 would be in an OK status. Now, the most important part of the policy is what we call the data elements. So what are data elements? It's really how you define the tokens for each sensitive field. And if we choose, for example, the address data element, you'll see that we chose an alphanumeric token. So that means we're tokenizing data that's either alphabetic or numeric. We're preserving the length. So a token that has 10 characters in input will also have 10 characters as output. We're not leaving any characters in the clear. So 00 means that we're tokenizing the entire string. If you were tokenizing a credit card and you wanted to leave the last 4 digits in the clear, you would choose here 4. And so only the first 12 digits would be protected. Now, there's multiple token types. There's tokens for, again, alphanumeric, alpha, specific for credit cards, numeric tokens only that are typically work for phone numbers or for social security numbers. And so here you define the data elements. Also, you can define masks. So there are some predefined masks, the typical last 4, first 3, a combination of both, and they're really easy to define. So for example, if I want to see the first 6 and the last 4 digits of a credit card, this is typical in PCI use cases. You'll see here, down here, the example, what masking character you want to use, a star, or a pound sign, or even a number, all 9s. Or even vice versa. So instead of first 6 and the last 4, I want to mask those first 6 and those last 4 and just show the middle part of the number. So you can play with the masks here and apply them to the policy. Then there's a section where we define roles and members. So I'm going to leave this page here. So there's some members that we have defined here in this demo platform. And then we put everything together. So for me, all these are the ingredients for the recipe. Now the actual recipe is the policy. So in the roles section, I've got several roles. I've got the unrestricted role here. So if I click on edit permissions, I'm going to see all my data elements and everything that the role unrestricted can do with the data elements. And it's basically everything. They can protect, they can unprotect, and the output is going to be in the clear. So this is what's available to unrestricted users. But if we go to a restricted role, you'll see that there are some differences. So let me go to page number 2. There is some more significant masks. Now I can unprotect, but instead of getting the clear value for the national identity number, I'm getting a mask that's last 4 digits. And what happens if I say, no, I don't want them to unprotect national identity numbers? I remove the check from the unprotect box. And now these options go away. Now I have the option to show a null value for national identity numbers, the protected value itself, so the token, or throw an exception, an error message. So again, there's options here to define each individual data element for a role. Once we're done, we click on the deploy button. Now this policy has already been deployed, so we can now move to our Greenplum platform where we'll run a few SQL queries to show you what it looks like from different users' perspective. Now, this is a dbeaver client that I'm using to connect to Greenplum. I'm already connected with 3 different users. And so I've got my user Leo, my user Wood E, and user Sanders A. So let's start with Sanders A. I've got a schema here with our tables. So if I show you what the data looks like in the table, even if I'm the fully most authorized user in the system, if I look at the table, so I click on view table, this is what you'll get. You'll get the data as it's stored in Greenplum. That means first name, last name, full names, email addresses are tokenized. Now you see here, there's a specific token that we use for email address. Everything before the @ sign is protected. Everything after the @ sign is in the clear. The national insurance number, again, since it's all numbers, it's hard to tell that it's tokenized, but you can tell by looking at the names or addresses. The street is tokenized as well, the postcode, and so on. And even the date of birth. Now, that's a good one to explain because the date of birth is sensitive, but we chose to leave the year in the clear. So we're only tokenizing the day and the month, but 1984 in this example here is the actual date of birth. So we can calculate the age and we can run analysis on the protected data. And I'll show you that when I show you the restricted user. So this is the base table, but what happens if I need to access the clear data because I'm fully authorized? Well, we have created a view here. And so I'm going to click on view, and that will show me the data unprotected because the functions will run. Let me show you actually the properties of this view. And if I go to source, this is the SQL definition of that view. So you see there's a Protegrity unprotect function that maps each field to the data element I just showed you in the ESA server. And so that means that the data will be displayed according to the policy for this user. But what happens if I show you, so let me close this connection and open the intermediate one, the user that's partially authorized. So I'm gonna click on the same exact view, click on view, and this is what this user gets when running the same query, a select star from the view. So most of the data elements are in the clear, except for national identity number and phone numbers. We're showing a mask. So this is dynamic masking because, as you remember, data is stored in the protected at rest, and I'm only detokenizing the last 4 digits at runtime for this specific user, and everything else shows up in the clear. Now, let me go to the last user, and that's the connection with Wood-E. And so the same view, once again, view, this is what this unauthorized user or whoever is not part of the policy by default would get, and that's the tokenized version of the data. So basically the same as running a query on the base table. We're not authorized, we're seeing everything tokenized, and this is what we get. But how do we typically work with our customers? We tell our customers that most users don't really need access to clear data. They can do their job with protected data sets. And let me show you a few examples. So if I open this session here, again, with user Wood-E, who's not authorized, there are some reports that can be run. I can view my clients by gender, and I can do aggregations. I can do age aggregations. Again, because the age is can be derived by the date of birth when we show the year in the clear, but not the full date of birth in the clear. And so we can run this analysis by age group on protected data. I can do something similar on the city and the state. However, you'll see now in a second that the city is protected. It's tokenized. So we know the state, but we don't know exactly what city we're looking at right now. But if we're doing some kind of investigation and we narrow down a few clients, we can then pass this information to someone who's authorized and can unprotect the values. But what's something I cannot do? If I look for someone whose last name is Colt, for example, and I try to run this query, it'll take a few seconds, and I'm not expecting to see any data from this query. And the reason is that I cannot see the name or the last name in this case in the clear. So I just ran the query, nothing came back. I cannot access personal information this way. However, if I am fully authorized, I can run this exact same query looking for data subjects or clients with the last name Colt, and this query will return a few of those subjects that share the same last name, and I'll get that in the clear. All right, that concludes our demo. Let me know if there's any question, anything that you'd like to know. Stop sharing.
We'll give folks another minute to see if they have any questions for us. But in the meantime, if anyone wanted to get in contact with either of you guys or had any additional questions, where would be the best place for them to reach out to?
Thank you. You go first.
So, yeah, so you can always contact me at venkatesh.raghavan@broadcom.com. More than happy to respond. That will be great.
And on the Protegrity side, you can contact me at marco.carmona@protegrity.com. And of course, happy to answer any questions.
Excellent, thank you. We don't have any questions in yet. I just do have a little announcement here for folks who are attending. We did have a great blog come out from you, Venki, introducing VMware Tanzu Greenplum 7.6, built for speed and resilience. I'll share that in the post-event email so folks can look into that.
Yep.
Marco, we can get some blogs from you or any announcements. We can also share that with the folks that are in attendance. And with folks who aren't in attendance, they'll be able to see that as well. And in case you guys were wondering, this has been recorded and will be available on demand shortly after the end of this presentation. So also make sure to share out this recording with the folks here in attendance. And then for the folks in the future, if you're watching the recording, hello, thank you for joining us. We're happy that you're able to check out this content here. So if you don't have any questions, any closing thoughts from you two before we close out today's webinar?
So the 7.6, what IJ mentioned, is going to be released by end of October. It's a precursor blog that's saying what's exciting coming. We have 7.7, which is also an exciting Greenplum release, both on security and query performance coming late December. So every 3 months we release a minor version for 7, and we have a lot of adoption of Greenplum 7. So looking forward to more people adopting Greenplum 7.
And on the Protegrity side, we have some exciting new releases coming out before the end of the year. There's already a developer edition, which is a Python SDK available on our website, protegrity.com. So if you want to start testing, it's a free edition, and something even more exciting is coming out in the next couple of months.
Awesome. Thank you both. Thank you, Marco. Thank you, Venki, for your guys' time, for your guys' knowledge and sharing everything that's happening with Greenplum and Protegrity. So thank you both. Thanks to all of you guys in attendance. Thanks for those who are watching live, those who are watching in the future on demand. Hope to see you at our next event. Everyone have a great week. We'll see you soon. Bye, everyone.
Bye,
Bye,
everyone.
thank you.
Thank you, AJ. Thank you, Marco.